Your now.
Thank you. Thank you. Sorry about that. So I will start again. So there are some objectives we are going to talk about. The first topic is function and function notation. And the objectives are to understand that function is a relation between two variables. Okay? Function is a relation between two variables. And we are going to understand the definition of function. And we identify the independent and the dependent variable in the function. And we are going to find the domain and range of a given function. Okay. Use the function notation to evaluate the function. So we will see function notation and we will see how to evaluate functions also. Sorry about that. Oh, my mic was off. Okay, let me start by definition. Looking at the definition here. So the first thing we are going to talk about is function. So function is a relation between two variables in which any value of the first variable. So the first variable is independent, so you can arbitrarily assign any value. For example, x is associated with exactly one value of the second variable. So for each x value, you should have a unique y value. So one y value. So keep that in mind. We say that the second variable is a function of the first variable. For example, if you have an area of a circle, you can arbitrarily assign the radius. The radius can be the independent variable. The area will be dependent on the radius, what is given in the radius. So what we say is area is a function of its radius. Depending on the radius, the area can be bigger and smaller. So for every x, there is only one y. Keep that in mind. For every x, there is only one y. So relation is a kind of function where each input will have a unique output. You cannot have multiple outputs. The second thing we are going to talk about is independent variable. So the independent variable is called input. Sometimes we call it input. Input to the function. Anything which is the input to the function is called independent variable. So you can easily arbitrarily choose any value for that. So the independent variable, because we can assign any appropriate value we wish to this value. Okay, so for the input, you can choose any value, but the output is dependent on this value. So it's called the input or independent variable. So the first variable, so in this case, x is the independent variable. That means we can choose any value which is appropriate to the function. What I mean by appropriate is, for example, if you have area and your independent variable is the radius of a square, radius cannot be negative. If you say -5 for radius, it doesn't make sense. So you have to choose positive numbers. So that's why we put the appropriate value right here in the sentence. So sometimes physically it doesn't make sense, or the function may not be defined if you choose arbitrarily any value. For example, in the case of area, if you choose a negative radius, it doesn't make sense because lengths cannot be negative. Okay. Now the next one is dependent variable. So the dependent variable is the second variable, which is called the output. So we call it the output. So the y value is the dependent variable. So it is dependent on x. So its value is determined by our choice for the independent variable. So whatever input you choose dictates the output. That's why it is dependent on the input. So we have independent variables, which are the input, and dependent variable, which is the outputs. The second variable is called dependent because it depends on what x value we choose for the function. Okay. Now with that, let's go to the next slide. and see this question. So now I want you to answer this question. Oh, sorry. We are here. So there is a formula for area. Area equals pi r squared. So we know that formula. So where a is the function of r, so we say a is the function of r. A is the function of r. Now the question is, which one is dependent? Which one is independent? Write your answer on the chat. Is A dependent or independent? Is R dependent or independent? First, let's figure out the okay, you are writing this. Okay, so first the independent variable. Which one is dependent? Which one is independent? So just label them. If one is dependent, the other one's. Okay, Jasmine says A is independent. A is independent. A is independent. Okay. R is dependent. Hugo, that's good. So, okay, I want you to see the relation. We said A is a function of R. A is a function of R. That means A is dictated by R value. So the radius is dictated by what R value we choose. For example, if I choose a small R value, I have a smaller radius. If I choose bigger R value, I have bigger radius. Sorry, biggest area, bigger area. So R is independent. A is dependent. Usually we write the independent variable on the right hand side. So if you see here pi r squared, that's the function. A is the dependent variable, R is the independent variable. So we can arbitrarily choose the radius and see what area we get. That's basically what you can just or look at this sentence. It says A is a function of R. A is a function of R. That means A is dependent on R. Okay. R is independent and A is dependent. Excellent, Hugo. Okay, now let's go to the next slide and we'll see more. Now, this is the function notation. We use function notation to represent functions. For example, in the relation we saw A is a function of R or Y is a function of X. So the output is our function. A function is often written using notation that indicates a relationship between independent and dependent variable. So the phrase Y is a function of X is represented by the notation. It says Y is the output. It says that is the output, is a function of X. X is the input or the independent variable. So the notation says Y equals f of X. This notation is called function notation. And inside the function notation, you have the independent variable. Independent variable. Okay, so it can be X, it can be T, it can be any variable, it can be A. So in this case, it's f of X. So whatever value you have inside here, it tells you that is the independent variable. So in this case here, Y is the output, X is the input. Okay, now if you see this two examples here, we have given a function Y, which is a function of X, and function P is a function of R. So we have, okay, let me write it down. Y is a function of X. So it is a function of X. So I will say f of X. So I will change this into f of X equals negative 3x squared minus 2x. That's how you write it in terms of function notation. I changed y into function notation f of x. Later I'll show you why we choose it to write it in the function notation. Okay, I'll definitely show you why we choose to write it in function notation. It helps you identify the different functions. The second one says p is a function of r. Now write down this in function notation. So how do you write p in function notation? P equals 13 plus r. Okay, type on the chat. PR. Okay, good. So you use PR, that's good. FR is good. So use small letters, okay? When you write FRP, so use the small letter. You are right, Jasmine. You are right, Norma. Hugo, you are right. Excellent. Yes, Jasmine. 13 plus R. Don't forget the R. Yep. So you guys already got that. But it can be any. So if you choose F, that's fine. You can choose G. You can choose H. Can use any variables. You can say P of R, that's also perfectly fine. If you say F of R, so F of R, if you have one function, just use F because it's function F. We usually use F, 13 plus R. But if you have multiple variables or multiple functions, use different F values. So I can write this as G of R, the same thing. It means a function G, and it will be helpful when we see a function. So I'll explain that later. And also I can say H of R, doesn't matter. If you say H of R, will be the same thing, 13 plus. Or it can be a P of R. Some of you already wrote P of R. It's perfectly fine. So P should be small, looks like capital. It can be capital letter also, doesn't matter. It's just to it will be helpful to identify the function. Now, if you see this, the answers, we already have the answer here, but it can be F of R or P of R, or this one can be G of R, sorry, G of X. Can be any, also they see the or and dot, it can be any. It can be H of R, it can be T of R, it can be Z of R, any variable you choose. Okay, now let's go to the next function. Sorry guys. Okay, now before we move, let me give you why we assign variables. Okay, now let's say I have 3 or 4 functions. Y equals 3x plus 1, y equals 2x squared minus 1, y equals 10x, and y equals square root of x minus 1. And also I will change it into function notation. If I have f of x equals 3x plus 1, because I have multiple variables, I'll change it into g of x. For the second one will be 2x squared minus 1. Let me change this into h of x equals 10x. When you have, let's say, p of x equals square root of x minus 1. Now I want you to see the difference between the two, and you can clearly see why we needed function notation in simple question. For example, if I ask you what is y y when x equals 2, which function are you going to use? If I say for the first part, so you have y different 4 different functions. If I say what is y when x equals 2, which function would you choose? Because all of them are y. There's no way we identify which function I'm referring to. Okay, that's the why we needed a function notation. Now, if I say what is g of 2, that means what is the second function when x is 2. So g of 2 means x is equal to 2. This means x equals 2. So x is replaced by 2. You can clearly identify this. We are talking about the second function. It has a name. It's called g of x. Okay, that's the difference. If it is not in function notation, you don't identify which function I'm talking about. If I say what is y when x equals 2, is it the first function, second, the third, or the fourth function? We don't know exactly. But if the function name is given, f of x, g of x, h of x, and p of x, when I say g of 2, you identify which function I'm talking about. It is the second function. Okay, that's why we needed the function notation. Okay, so that's another example. I mean, usually it would. I mean, if you have one function, use f of x. Yeah, it should accept any, but it may give you instruction. So I'm answering Norma's question. It says our text is very sensitive with syntax. Will it accept any of the 3 terms? G of x, f of x, you can use any of them. It doesn't matter. But if you have a single function, usually use f of x. But if you have multiple functions, you have to change because it is named. So you have to say f, g, h, p. You can use any term. Okay. Do you guys understood why we needed function notation? Any question? Did you guys understood why we needed function notation? From this example, I mean. So it helps you identify which function we are talking about. It's like naming functions. If I say f of 2, you know I'm talking about the first function. Usually we use small letters, not capital letter. Use small letters. You can see on the book also. We usually use small letters. Don't use capital letters. Small letters is better. If you have, for example, 2 functions, these are f of x, then use g of x. Common, very common. H of x, very common. So if you have multiple, use h of x. I mean, in the homework, definitely will give you, it will say what is f of this, and you put the number or the variable. I don't think it will be a problem. Okay, but usually use a small letter. Okay. So if you have a single function, use f of x. Always use f of x. That's fine. Okay. Now let's go to evaluating functions. So the next topic is evaluating functions. I have 3 examples here. Now, before we move to evaluating functions, in the notation, if you have, let's say we have f of x, and if I say f of 1, what I mean by is I'm replacing x by 1 and x equals 1. That's basically what this means. Replace x by 1. Okay, x becomes 1, x equals 1. Whatever number you have inside the function notation, inside the parentheses, that is the x value. So for example, this is the function given. Evaluate the given function. whenever possible. So it's whenever possible. Sometimes it's not possible for some functions. It may make it undefined, or you can't evaluate the expression. So if you see this function, it's f of x equals 3x squared minus 2. This is quadratic function. Now, if I say f of x, that means the function is a function of x. So we have to identify the x value first. Before we solve or evaluate the function, the first thing you do is identify what is the x value. Now, if you see A, it says f of 0. That means x equals 0. That's the first thing you have to identify. The second one, it says f of 1 over 2. That means x equals 1 over 2. The third one says f of negative 2. That means x equals negative 2. So what that means is x replaced by 0, 1 over 2, and negative 2. Now let's evaluate the function. So when I say f of 0, I will replace the x by 0. So you have 3 0 squared minus 2 because x is 0. So this equals 3 times 0 squared is 0. So 3 times 0 minus 2. And 3 times 0 is 0. 0 minus 2 becomes negative 2. So f of 0 is negative 2. Simple. Any question on this example? So the first thing you have to do is identifying the independent variable. What is x? In this case, it is x. So when I say f of 1 over 2, it means x is 1 over 2. Now let's evaluate this one. So f of 1 over 2, just replace x by 1 over 2. So we have 3x. Now x is 1 over 2 squared minus 2. 1 over 2 squared is 1 over 2 times 1 over 2, which is 1 over 4. 2 times 2 is 4. So I have 3 times 1 over 4 minus 2. So 3 times 1 is 3. So this is 3 over 4 minus 2. Okay, what is this number? Anyone? Just work on this number and give me your answer on the chat. I want to see if you guys are good in working with fractions. So what is 3/4 minus 2 over, technically 2 over 1, and make it the same denominator and simplify. So what is 3/4 minus 2? Negative 1, okay. One over 3. Any different answer? Write your answer. It's okay. It doesn't matter if you missed it. Good judgment. Your answer is right, but not in decimal. It should be in fraction. So in your my MATLAB maybe it asks you in fraction. So it has to be in fraction. Negative 1 over 4. Excellent, Norma. 1 over 3. I see different answers. Okay, now I want you to pay attention here because I see different answers. I want you to pay attention how to subtract fraction. So when you have fractions with different denominators, the first thing you do is make the denominators the same. So I see here 4 and 1. So the LCD is 4. So I have to make each one of them 4. So the first one is already 4. So I have to multiply this by 4 over 4. 4 over 4 to make it the same denominator. So now this becomes 3 over 4 minus 2 times 4 is 8 over 4. If you have the same denominator, you can add or subtract the numerator. So you keep the common 4, then we have 3 minus 8. 3 minus 8 is -5/4. That's the answer, okay? That's how you simplify fractions. Make the denominators the same. After that, if it is addition, you add. If it is subtraction, you subtract. Any question? So -1.25 is right, but it has to be in fraction. I will do another one, maybe. I will do another one. Okay, do another one. Okay, now C. Yeah, I mean, it should be in fraction form, but the -1.25 is the same as -5/4. Okay, the second one here is f of -2, so that means x is -2. So f of -2 equals 3 times -2 squared minus 2. So -2 times -2 is 4. So you have 3 times 4 minus 1, minus 2, I mean. 12 minus 2, which equals 10. So f of -2 is 10. So it is important to evaluate functions because when we are going to study how to graph them, you need to find x and y in ordered pairs. So that can be achieved by function evaluation. So you have to know how to evaluate functions, to graph them and solve them, to use the function in different ways. Okay. Okay. Now let's do some examples. Now I want you to try this 2 examples, and I have more examples, and we'll discuss about them in the next slide. So try f of 1 and f of -2 given the function f of t equals 3t minus t squared, t cubed. I mean. So once you finish, type your answer on the chat. First, identify what is t. Very good, Norma. Identify what is t. So when it says f of 1, that means the independent variable is 1. In this case, it is t, so t is 1. When it says f of -2, the independent variable is -2. Okay, good. So A is 2. Very good. What about B? Now work on B. Okay, -14, 2. Okay, good, good. So I see different answers. That's okay. So the common answers are -14 and 2. Now let's do it together and see which one is correct. So this one is just 3 times 1 minus 1 cubed. So 3 times 1 is 3. Minus 1 cubed is 1 times 1 times 1, which is 1. So this equals 2. Excellent. So you guys got the first one right. Now the second one, t is -2. So I have 3 times -2 minus -2 cubed. Now -2 cubed is -2 times -2 times -2, which is -8. So I have -6 here minus -8. Now, if you guys remember last time we said we can change subtraction into addition, and you have to switch the sign of the second number. So you have -6 plus 8. So minus makes it plus. When you see minus minus, negative times a negative is positive. So, and we said if you add two numbers with different sign, you subtract the numbers, which is in this case 2. 8 minus 6 is 2. And you keep the sign of the number with biggest magnitude or highest. In this case, 8 is bigger than 6. Bigger absolute value. That means 8 is positive. That makes the number positive 2. So you have f of -2 is positive 2. Excellent, Hugo. He has got the number right. So those of you who got negative 14, I think you thought this is positive 8. So negative times a negative is positive here. 4 times -2 makes it -8. It's not positive 8. Okay, that's why you get that mistake. Now let's see some examples which will give you some first A with fraction. So some of you asked to do problems with fraction again. So we have this chance. Now I'll do A, then I'll wait for you guys to do B and C for at least 4 minutes. Then we'll discuss about the answer for B and C. Okay, now let's do A. Says what is h of negative v? Given h of v is v plus 1 over v. So it says h of v is v plus 1 over v. So all you have to do is substitute v by -3. So it becomes -3 plus 1 over -3, which is -3 minus 1 over 3 because of the negative. So negative times positive is negative. Now, if you see this number, they don't have a common denominator. So this is over 1. So I have to multiply by 3 over 3 to make the denominator the same. So I have to multiply this by 3. I have to multiply this by 3. So 3 times 3 is -9 here, over 1 times 3, which is 3, minus 1 over 3. So if you see now 3 is common, so I'll take out the common. Then -9 minus 1. So this is -1. -9 minus 1 is -10. Over 3 will be the function value at v equals -3. Okay, so I hope this one makes it clear on how to subtract. For the last example, it was 2, but f was -2. I didn't get that question exactly, but let me go back. Okay, first everyone copy the function h of v, which is v plus 1 over v, and the question B is size h of 0 and C size h of a. So I want you to pose h of 0 and h of a. So right now we are at 640, and we'll come back at 644, and we'll talk about the answers. Okay. Let me go back to the previous slide, and yeah. So f of -2 means t is -2, and the function value is 2. When you plug in -2, you get 2. Yeah, sometimes it happens. F of 2 can be 2. Doesn't matter. Sometimes you may have a function which is f of 2 is 2. For example, let's say f of x is x. F of x equals x. When you plug in 2, f of 2 is 2. So it can be the same. In this case, f of -2 is 2. Sorry if I didn't understand your question, but Yes, f of -2 is 2 in the previous example. Okay, now work on B and C. And when you finish, type your answer on the chat. Then we'll discuss about the answers. So B will lead us to the next topic we are going to talk about. And H will revisit that in another topic. So I don't know if it is included in this chapter, but if it's not included, it's okay. But B definitely show you something for the next topic we are going to talk about. So what is h of 0? That was exactly the question, Jasmine. So she says, can we solve B if the number is divided by 0? Excellent, Abhi. Yeah, so if a number is divided by 0, it is undefined. So h of 0 is 0 plus 1 over 0. Because this is undefined, so we said h of 0 is undefined. Excellent. So this makes it undefined. So from this function, v cannot be 0. So 0 should be excluded. If v is 0, it makes the function undefined. Excellent. Now, what about h of a? H of a. What it means is now a replaces v. Can be number, it can be variable, it can be expression. Sometimes can be symbol. Okay? I can say, for example, yeah, type your answer. I can say h of star. Doesn't matter. Oh, sorry, mine. That's bad. Whatever number or whatever symbol or whatever expression you have inside h will replace v. That's basically the concept of evaluating functions. So write your answer. You got a over a. All you have to do is just replace v by a. Okay? Replace v by a. So OB, you have v plus 1 over v. So v becomes a. 1 over v becomes 1 over a. That's all you have to do. What this means is a replaces v. That's it. Here the star will replace a. You have the star plus 1 over the star again. Sorry, doesn't matter what symbol or what number you have inside, it will replace v. Yes, Dan. Excellent. That's basically what function evaluation is. Yeah, don't overthink it. So whatever number or expression you have inside the function notation replaces the independent variable. That's basically what function evaluation is. Function sometimes can evaluate a function. So if see the star replaces the b. Okay, now let's go to the next topic. Now the next topic is domain and range. Domain, when I say domain, it means set of all input values. Okay, set of all input values or X values. Range is the set of all output values. So usually we put them in ordered pair. So the domain comes first, the range comes next. So the first number is the domain, the second number is the range. So the domain has some restriction for different functions. So at this level, we are going to consider only two kind of functions. One, square root. So if you have a square root of, let's say, g of x, expression inside the square root cannot be negative. Okay? Because if it is negative, it becomes undefined. For example, square root of -4 is imaginary number, it's undefined. So g of x cannot be negative. The expression inside can not be or should be positive. This is use rather than using negative. I'll use should be positive. Should be positive, or it cannot be negative. Okay. So what this means is g of x should be greater than or equal to 0. Any number you see inside the square root should be, any expression should be greater than or equal to 0. If it is less than 0 or if it's negative, it makes the expression undefined or imaginary. It's undefined. The second one is, let's say you have 1 over f of x fraction, or c, some constant, any, let's say this is c. If you have expression in the denominator, that expression should not be 0. F of x cannot be 0, or f of x should be different from 0. Should be different from 0. From 0. So mathematically, we can represent that f of x should be different from 0. So any number that makes f of x equal to 0 should be excluded from the domain. Any number that makes f of x equal to 0 should be excluded from the domain. So there are two restrictions. It's simple. All you have to do is first locate the function. What is the function? If it is a square root, the expression inside should be greater than or equal to 0. So if you see example 1 here, when I see this function, I see radical. So the expression inside, which is x minus 3, should be greater than or equal to 0. That means we add 3, so we know how to evaluate, solve inequalities. That means x should be greater than or equal to 3. That's it. That's the domain. The range is the possible y values. So at this level, we are not going to talk about the range. So the domain is x greater than or equal to 3. So you can't use any number less than 3. If you use any number less than 3, it makes it undefined. For example, if I choose 0, a number less than 0, so less than 3, I mean, if I choose 0, it becomes the square root of 0 minus 3, which equals the square root of -3, which is undefined. So the numbers has to be greater than or equal to 3. Okay, now what is the domain for the second one here? Number 2 is on the right. What is the domain for number 2? Write your answers on the chat. What is the domain for f of x equals the square root of 2x plus 5? Domain means the possible input values. Some input values are excluded depending on the type of function. So for the square root, anything inside the square root should be greater than or equal to 0. It cannot be negative. So what is the domain? Norma, thus the expression, it should be a number. So it should be some kind of number, cannot be 2x plus 5. So, okay, 3. Okay. So let me write down the expression for you, and I want you to solve it. So when you see the expression inside here, it's 2x plus 5. It should be greater than or equal to 0. That's the domain. Okay. So all you have to do is just solve this. Negative 5. It should be greater than negative 5 over 2. Excellent. So you solve like when you solve inequalities, we talked about it. It's similar to equation. The only difference is when you divide and multiply by a negative number. Otherwise, it will be the same as solving equation, linear equation in this case. So x should be greater than or equal to negative 5 over 2. Any number below this is not acceptable in this function. So the domain is x should be greater than or equal to negative 5 over 2. Okay, the next two questions are called rational functions. So we have a denominator. So anything that denominator should be greater than different from 0. So in this case, in the first one, domain here, x should be different from 0. That's it, different. So this means not equal to, okay? Not equal to or different from 0. So all real numbers except 0 is acceptable, but 0 is not acceptable. If you input 0, you'll have 1 over 0, which is undefined. So all real numbers except 0. That's basically what it means. X cannot be 0. Any expression in the denominator cannot be 0. So in this case, x minus 5 should be different from 0. So what is the domain now? You can see it from the equation. What is the domain? What x value is excluded from the first example? Okay, guys, solve this one. Just like equation, basically what it do is just solve the equation, and that value should be excluded. If it makes the expression equal to 0, that means it makes the function undefined. What x value makes, the question is what x value makes x minus 5 0. What x value makes x minus 5 0. Normal, that's not undefined. Yes, it should be different from 5. So x, so you just add 5. So x should be different from 5. All real numbers except 5. All real numbers except 5. Okay, good. So let's move to the next one. So in the next slide, I'm going to show you how we can represent a function. Functions can be represented as ordered pairs, x and y, or in function notation, like we saw that y equals some function of x. And we are going to identify if the given relation is a function or not. So the first three here is called an ordered pair, an ordered pair. Now, in a given ordered pair, to check if the relation is a function, check if the x value. So the x value means the first value. So the ordered pairs are always x comma y. Okay. Now, the x cannot repeat itself. If x repeats, that means for one x value, you have multiple y value. So when we define function, we said each x value should have a unique y value or one y value. If x repeats, that function is not, that relation is not a function. If x does not repeat, that is a function. So x repeats, that means not a function. So all you have to do is just look at the x value. So if you see here, we have 1, we have 3, we have 5. X does not repeat. That means this is a function. Now for number 2 and 3, which one is a function, which one is not? So let's say this is 1, this is 2, this is 3. So identify if it is a function or not. Yes or no. Just number 2, is it a function or not? Just type yes or no. Look at the x value. If x repeats, it's not a function. If x does not repeat, it is a function. Excellent, Hugo. Excellent, Norma. So number 2, we are talking about number 2. The y doesn't matter. We don't look at the y value. Good question, Norma. We don't look at the y value. We look at only the x value. So if x repeats, that's not a function. We don't worry about the y value, only the x value, only the input. Three is not a function. Excellent. Very good. So if you see here, this one repeats. So this is not a function. This one, it doesn't repeat. So we have 1 and 3. So this is a function. Okay. Now, if the function is given in a function notation, like y equals x squared plus 1, or y equals, if it is given as an equation, what you have to look for is the y value cannot be squared. If the y value is squared, that means x value can take two different y values, okay? And you will have the same value. For example, if we see here, the y value is single, that means for each x value, you have a single y value. Here also you have y value single. For each x value, you have one y value. But in this one, if you see here, y value is squared. So for each x value, you can assign two different y values. And it will be the same. For example, y negative 2 and 2 will give you the same value because negative 2 squared is 4 and also 2 squared is 4. You will have the same x value. For that reason, this is not a function. These two are functions. So in simple terms, the exponent in the y term cannot be even power. So if the exponent in y is even, that's not a function. It's not a function. Okay. So, for example, if I say the same function, but I would change it. 9 equals x squared plus y cubed. This one is a function because the exponent is odd. If the exponent is even, that's not a function. Okay. So basically, all you have to do is look at the y, and if the y has even degree, it is not a function. Like y squared or y to the power 4. This one is not a function. Let me show you. If this is y to the power 4, this is not a function. This is a function. Yeah, it's a little bit tricky, but all you have to do is look at the y, and it cannot have exponent which is even degree. Even like 2, 4, 8, 2, 4, 6, 8, and continues. Okay, that's how you identify if the given relation is a function. Yeah. Okay, now let's go to the next topic. The next topic is simple. So we have 20 minutes. We are going to take the 20 minutes in 4 slides. So what I will do here is the objective will be to introduce rectangular coordinate system. That means XY plane. Identify quadrants, x-axis, the axis, the origin, the ordered pairs, and the coordinates. How we can locate the different axes first, how we locate the quadrant. Because we have 2 different axes, you have 4 different quadrants, 1, 2, 3, 4. So we identify which quadrant an ordered pair will lie, and also we'll see the origin here. The middle point is the origin, and the axis. We have x-axis here and y-axis. I have a slide to talk about that. Okay, now the last and the most important one is graphing a point in a rectangular coordinate. This one is very important because we are going to graph functions. To graph functions, you have to know how to graph or plot a point in a rectangular coordinate system. How to locate where the point is and how to plot that point is very important. Okay, now let's discuss that in the next slide. Now the next slide, this shows you the different components of the rectangular coordinate system. The first one is the origin. So this value, the place where the 2 planes meet, is called the origin. We have 2 axes, x-axis and y-axis. So the x-axis is horizontal, left and right, left, right. The y-axis is up and down. So the y-axis goes up and down. Okay, and we have 4 different quadrants. The first quadrant, the second quadrant here on the left, the third quadrant, and the fourth quadrant. So this means 1, 2, 3, 4. We use Roman numerals. Okay, these are Roman numbers. We don't use the Arabic number 1, 2, 3. We use Roman numerals. So when you see 1, it means the first quadrant. Now, if you see point P, when we plot points, we usually start from the origin, move the ordered pair starts from x and y. Whatever x value you are given, locate that x value, then locate the y value again. So y value, it can go up. If it is positive, it goes down if it is negative. So always start from the origin, then move to x. Then from that x value, move up and down depending on the y value. So if you see P35, First, we move 3 units to the right. So you move 3 units to the right. After that, you have y equals 5. So we move up to 5. So this is 3. This is 5. So we always start from the origin. Then we move x unit, whatever x you have. If it is negative, we move to the negative. For example, let me give you another number. Q, let's say it is -5 and -7. Okay. So to locate Q, first I will start from negative the origin. Let me use different colors so that you can see what I'm doing. So I will start from the origin. I go 5 units to the left. So from the origin, I will locate -5 on the x-axis. Then from -5, then I will go down by 7. So -7 is somewhere here. You can see here, it's somewhere here. So I will go down here. So this is Q, which is -5, -7. Don't transpose the point. Sometimes the students move the x and y and they transpose them. So plotting -7 and -5, they are totally different. So these are not the same. Okay, so always start from the origin, move to the x value, then move up and down depending on the y value. Okay, so next we'll see how to locate each point, how to plot each point. Now, I want you to copy this, all this 1, 2, 3, 4, 5, 6 points, and we are going to practice how to locate them in the coordinate plane. Okay, everyone copy the questions. Very good. Someone said it's in quadrant 3. Yeah, that's normal. Yeah, that's normal. So we are going to see that also, how to locate a point in which quadrant the point is located. So now we'll copy A, B, C, D up to F. Copy this. Then we'll talk about, we'll plot them. Okay. I'll use the whiteboard and I will let you plot the points. Okay, here we go. Let me draw the coordinate plane first. Okay. So the maximum point is 5, so I'll plot 5 by 5 coordinate plane. We call this a coordinate plane. Okay, so we have 1, 2, sorry. So this is 2. Oh, don't worry about it. I think you can easily identify them. So my pen is too small. I don't know why. This is 2. Okay, I'll open it for you guys to locate A, B, C, D, and E up to F. Just type A where A is located. Type B. So let me start with A. So A says 4, 1. So A is exactly, Diana got it. So A is right there. Yep, that's it. So A is right here. So locate B, locate C. Just type randomly. So anyone can work on B, and another one can work on C. So locate the point so that I can see the point. Make sure it is a straight line so it will not be confusing. Oh, Norma, it's too big. You are writing too big. You don't have to show me where it goes. It's just plot the point. Just look at, just put the point. So, for example, if it was something like this, I would put just a dot, okay, like that. And we will level them. So clear your, okay, guys, you have to clear. Just clear. Good. There's, okay, excellent, excellent. Now just look at the points. So I'll also clear the green one here. Use a little bit. Okay. So Norma, what is that? Is that B or C? So we already have B here. C. Okay. So C is -3, -2. So -3, -2 right there. Very good. So -3, -2 is C. So one of the point is C. That's E. Someone would put E. It is E is -50. Very good. So -50 is somewhere here. So one of the point is E. So we have D also. Someone wrote, is that Dan? I don't know who wrote D. D is 4, -3. Very good. So 4 here. Then we got -3 right there. Excellent. What about F? Do we have F? Did someone wrote F? So we have A, we have B, we have C. Excellent, Abby. I think he's located. Good. Yes, F is right here, 0, 2. Very good, guys. Everyone who participated, this is the correct answers. So I think this is C here. This is E here. E. This is F. And we have B. Very good. So this is a B. We have A. We have. Sorry, what is that? 4, -3 is D. So this is D. Excellent. Excellent. So we have now 6 minutes. So we go to the next slide. Oh, sorry. In the next slide, we are going to talk about how to identify if where the given function is, where the given ordered pair is. Is this in the first quadrant, the second quadrant, third quadrant, or the fourth quadrant? Okay, now the quadrants, if you see here, the first quadrant, the coordinates will be positive and positive because x and y are positive. If the numbers are both positive, it is in the first quadrant. In the second quadrant, x will be negative, y will be positive. So this is the second quadrant. In the third quadrant, both of them are negative. So this is the third quadrant. Both of them are negative. In the fourth quadrant, x is positive, y is negative. Okay. Now, if you see number 1, x is negative 4. That means either is in the second quadrant, in the in the third quadrant. And y is positive. That means this is in the second quadrant. Quadrant number 2. So -4, 3. The next one says 5, -2. So x is positive. So it's either in the first quadrant or in the fourth quadrant. So you can see it here. So if x is positive, that means it's either in the first quadrant or in the fourth quadrant. So if you see here the y is negative, that means it is in the fourth quadrant. So let me use Q for quadrant, okay? Q represent quadrant. Now, what is number 3? Where is number 3? It says -3, 0. Where do you think is number 3? -3, 0. Quadrant 4, okay? Anyone? Where do you think is -3 and 0? Now, numbers which are on the axis are will not be included in any quadrant. So this one is on x-axis. So -3, 0 is somewhere here. -3, 0. So it is on x-axis. It's not in any quadrant, okay? It is on x-axis. Now, what about number 4? Which quadrant is -3 and -7? -3 and -7. In which quadrant is -3 and -7? Oh, sorry guys. Sorry, I forget to present. Oh. So this is what we are working on. I don't know why. Oh, okay. Okay, good. Excellent, Norma. -3 and -7 is in quadrant 3. -3, -7 is in quadrant 3. So this is quadrant 3. Now the last one is 0, -2. x0, y, -2. In which quadrant, or if it is an axis, in which axis is it? It is in on the y-axis. Excellent. Yeah, so this is on y-axis. It's not in any quadrant. Okay. This is how you identify where the numbers are. So just keep this in mind and see the sign, and will guide you which point is in which quadrant. So the last example, if you see here, to identify quadrants, even if we are not given the numbers. So the ordered pairs are given with condition. If you see here, A says x, y is given in such way, or if x is greater than 0 and y is less than 0, where does x, y located? So we are given an ordered pair with condition. So the conditions are, if x is greater than 0, that means x is positive. And y is less than 0, y is negative. So we are looking for positive and negative. So in which quadrant do you have positive, negative? Look up here on the right hand side. The fourth quadrant, exactly. Positive, negative is in the fourth quadrant. Now give me the quadrant for B. XY is given that x is less than 0, which is negative. Y is also less than 0, which is negative. So in which quadrant do you get negative, negative? Excellent, Norma. Excellent, Jasmine. So that is the third quadrant. I think Abby is also writing. Excellent, guys. So this is the third quadrant. Okay. So we are right on time. It is 7:20. Any question? Do you guys have any question? So basically what we studied today is functions and function notations and evaluating functions, identifying if a given relation is a function, and we learn about coordinate planes and how to locate a point and how to plot a point on a coordinate plane. Any questions? Okay, quiz 5, if you are not able to access it, I'll check it and I'll make sure I'll update it. So some of you said you're not able to access quiz 5. So I will